G'day guys, Alan here. Welcome to my workshop. Regular viewers will know that I recently bought a new lathe, and there's a couple of videos on the channel that talk about that. And there's a lot that I like about that lathe, but a few things I don't. And in this video I want to talk about the threading dial indicator, or TDI, and I think it's also known as a thread chaser. Now my lathe has a metric lead screw, and to get the commonly used metric thread pitches supported by that TDI, it has to be able to use 3 gears, the little sprockets that sit on the end of a shaft and engage with the lead screw. And it comes with a 14, 15 and 16 tooth gear. And each of those gears has to be associated with a set of marks on the dial on the top of the TDI. Now the factory supplied item, and we can have a bit of a quick squiz at it here, it's a pretty standard sort of thing. Comes with a threading chart on the front face that talks about the thread pitch that you want to get, the number of teeth on the gear that you need to use, and the index number. And the 3 gears come on the spindle, and you just juggle them around so that the one you need is on the bottom. The thing that I don't like about this, although it is in fact a very compact solution to the problem and presumably cheap to make, I don't know how well I can hold that so you can see it without the light reflecting off it, but the dial, well, if it doesn't show up very well I'll put another picture in. Anyway, the dial has 3 sets of markings on it overlaid on each other. There's a set of 5 equally spaced ones marked with a 5, 3 equally spaced ones marked with a 3, and then some 4 other ones which are marked with 4s, 2 and 1, and it's all a bit bloody confusing. And when you don't use it all the time, you look at this lot and you think, what the hell am I supposed to do with that? So it does all make sense when you think it through, but then when you drive in the machine having to work quickly, sometimes it isn't so easy. So what I've decided to do is to make up some additional spindles and break this out. So I've got one here which I've already made. I haven't put the index marks on it yet, but my idea is to have 3 of these things, and put one, have one with a set of 5 marks on it, one with a set of 3 marks, and another one that's got the 1, 2 and 4 mark on it. And in that way I think it'll be a much simpler dial to actually use. I've rounded up some scrap material from a local engineering shop. I've got all these little bar ends, so one of these is about perfect to get one of those out of. So there's 2 parts to this job. One is to turn those spindles, and the other then is to go over to the milling machine in the rotary table and to mill or engrave the index marks on the top. So that's enough talking. Let's get over to the lathe and start turning. So we're going to start by cleaning this end face up and centre drilling it. Okay, so I'll be putting this in here with not very much in the chuck, and the tail stock on the other end. So to make sure it doesn't disappear up the hole, I'm going to slip in my simple chuck backstop. Leave that loose for a moment. Bring up the tailstock support. So I need to have something like 90 hanging out to work with, which I've now got, so that's good. The diameter of this bar stock I think is 31.75. Yep, pretty close at least. Because I'm making one of these, we'll just start from here and turn all these diameters down progressively. So the largest diameters are at the end here, that's this 30 millimeters here. This is not a critical dimension at all. just doesn't want to be more than 30, but if it was a, I don't know, a couple of points below, it wouldn't matter. So we'll aim at 30 and we'll see what we get, and I'll just go in one pass. So let's see what we got. It's a lovely finish. Something's gone badly wrong there. We're down to 29. What did I screw up there? Well, I don't know exactly what it was I did wrong there, but thankfully there's enough material that I can recover, because I only need to have 5mm at 30, so I get a second chance. See if I did better that time. Right, well the next cut is to get down to a small shoulder, which you mightn't be able to see very well there, but that's 16 diameter. And so we need to bring most of this down to 16 and leaving enough for this up there. So I'm going to take 4mm, reduce the diameter 4mm at a time, so 2mm depth of cut. Well, got to be happy with that. So I've just got to clean this area up now to create the shoulder that I want. Right, so I've cleaned that face up and recalibrated myself. So the next feature I'm doing is this small shoulder there. So that's 16 OD on that shoulder and 12 here. So I've got to go 12 up to just a bit short of that face. All right, so I've increased the speed because the diameter is getting down a bit now. And we're going to go take this 16 down to 14 in this pass. Till within 0.8 of this face, at least that's the plan, if I don't stuff it up. We've got the dimension we're looking for, so that's good. Meaning this thing should fit on there now. Well, let's check. Yeah, happy with that. That's a much better fit than the original factory item was actually. Okay, now we've got to get this part of the shank down from 12 to 10 for a length of 45. We go to 11 first and then check. 10.009. Well, let's see if the gear fits. Guess that's what counts. It's a bit tight. I might have another go. It does go, but it's a bit too tight. So let's go on 998. Or 9.99, I guess. Oh, well, let's see how the gear fits. That's what really counts here. I can't change the size of the gear, but I can make the spacer to fit. Oh, that's nice. That is perfect. Alright, well I'm happy with that. Like I say, there's only a spacer to go on there, so it doesn't matter if that isn't a perfect fit. Let's see whether the spacer I made for the first one will fit. So that goes on nicely now. A nice snug fit, because that's not a running fit, that's just got to get there and stay there. And then the gear has to go on the bottom. Perfect. Right, so in fact I don't have to shorten this, I don't know whether you can see, but all it was needed to be was that the end of the shaft had to be lower than the outside face of the gear, which it is. So all I've got to do now is drill the M5 hole and, drill the 5mm hole and tap it for M6, and then we're a long way forwards. Bit of the green goo. Stuff seems to work quite well. Mind you, there's a million different sorts of tapping goos out there. Everyone seems to have their favourite. Right, let's get going. Right, just clean the end up a little bit. Right, and we should be good to go with the screw. Okay, well, let's take it out and do a test assembly, because we've got to turn it around in the chuck now anyway. Okay, well, I think you can see that it's gone together quite well. The screw in the bottom holds it all together. You won't be able to see it, but there is, I don't know, a couple of thousandths maybe of end float there, which is just required for clearance. So what we're going to do now is lock this off to produce the head at the right thickness. So back into the collet chuck for that. And we get the rest with a hacksaw. Not sure why I've got that pattern there, but I don't suppose it matters very much. Right, I'd say he's done. Okay, I've made my 3 spindles, and that seems to have worked out just fine. The spacer, and any one of the gears. It's all good, and the screw goes in the bottom to hold it all together. So, time to turn my attention to doing the markings on the top. And just to remind us, the whole point of this exercise is to to do away with the 3 sets of markings on one dial and have 1 set on each of the 3. Make it easier to read. Now, one thing you might notice though is that the original dial is only 2mm thick and mine are much thicker. So why, might you ask? Because it obviously creates the potential for parallax error because they're so much thicker. But I actually had 2 things in mind. The dial of gradations, of course, but also it's a bit fiddly when this thing is installed, undoing the nut and whatever. So what I had in mind was to make up a pin spanner and put 2 pinholes here, or 2 holes for the pins. So I needed a bit of meat to do that. So to solve this problem, I've got to put a bevel on the edge here. And to do a practice on that, I've made up this from another bit of scrap. And so by going 60 degrees and coming nearly 3mm down, I finish up with a band 5mm wide, which is allows me to have marks. These marks are 5mm long, so I better get 5mm long marks on here and have room for the 2 pins. This is just some bit of scrap that was lying around. It's actually 2 pieces that were brazed together in a distant universe. But anyway, it's good enough for me to practice on, because I need to work out how to get a centre line, find the centre. Anyway, let's go over to the milling machine and the dividing head and see what I'm talking about. Okay, as you can see, I've got the rotary table sitting on the milling machine, and I've got a ground parallel sitting in one of the T-slots and a 90-degree square. So the first thing I want to do is find the centre of the piece that I'm trying to put the marks on, and having the table at 90 degrees, the rotary table at 90 degrees will make that easy for me, because I can go across the diameter. But when I've done that, I need to swing the table around 60 degrees so that I can put the marks on the bevels, and so this setup will easily allow me to do that. So 60 degrees there, just swing that around to that. So very easy. I've got the table held down with 2 bolts, one here and one at the front on the opposite side. I won't be putting any force on anything, so that is going to be ample clamping. So let's swing around to the front side and have a look at how I'm going to find the centre. Okay, for this part of the setup, I've got a holder which I machined up out of a bit of scrap, and a short piece of round tool steel held in with a grub screw from underneath. And you can't see it very well, but the end is ground to quite a fine edge, which makes it a very effective scriber. So the idea, of course, is in the first instance to do a couple of witness lines across the face here to test whether I'm actually on centre height. So I've set this by eye at the moment, and I'll do one and then rotate 180 degrees and do another one. And if I've still only got one line, I'm obviously on centre. Otherwise we'll have to make an adjustment. But I'm troubled with this sort of thing because my eyesight's not that fantastic. Anyway, let's give it a go, see what we get. So we'll set the rotary table on 0, just so I don't have to remember fancy numbers. Oh well, there's 180, let's use that. Alright, we're on 180 there. There we go until we touch off. It's going to be tricky in itself, so I can't see properly. Yeah, so I don't think I can do anything to make the line show up for the camera. I can barely make it show up for me. But anyway, there is a line there. So we'll move away, rotate 180 and do another line and see what happens. And like that, I'd say. Lock that. So line's on this side now. So come this way a little bit. Oh, go back, sorry, not like that. Yes, I want to see a bit of an overlap between the two lines so I can work out how much I've got to go up or down. Anyway, let's go to 0 here. Okay, move away from that so we can see it properly. Okay, it's pretty hard to get a picture of this, but I think perhaps you can see there it's got what looks like one line, but it's actually a line done in 2 halves, one from each side, so therefore I know that I'm right on centre, or close enough at least, that it's good enough for this exercise. Well, I'm sure it isn't quite perfect, but it's going to be good enough for this. Okay, one aspect to this which I didn't mention before is for this lot to work, clearly I don't want the spindle to rotate. So I've made a very crude spindle lock. I did this for some other projects a while ago. And so the end of the quill has 2 drive dogs in it. Or sorry, end of the spindle I suppose, has 2 drive dogs in it for driving the bits, the holders. Anyway, so I took one out and replaced it with my own machined up thing, and it's just a clamping screw. You probably can't see it, but there's a brass cap on the end of it, and it just bears on the end of the quill with enough force that it stops that from turning. I'm sure if you reefed on it, it would slip, but it's sufficient for this. Alright, so now we've got this on centre, it's time to turn this around to 60 degrees, as I mentioned earlier. When I swing it, I won't lose the centre height, but I will lose the axial positioning, unfortunately. C'est la vie. So let's spin this around. And so we've got to come back this way a little bit too. Alright, now we've got to get zeroed here on the beveled face and get ready to go with the rotary table. Now I don't know whether you'll be able to see this, but now I've got this turned around, I can see that I'm in fact not right on centre. I'll try and take a better photo or a specific picture so you can see it. It's not very much out, it's hard to quantify just by looking at it. It might only be 0.1 or 0.2 of a millimetre out, but it's just slightly off. Let's see whether I can take a photo. Okay, so I can see that the second line is a bit lower than the first line, so the scribe ideally should come up a very small amount, and the distance between the two lines isn't much to start with, so should really only come up half of the distance between the two lines, and probably the least amount that I can move it is about 0.05. So let's come up 0.05 and call that it, and we get what we get. That's up 0.03 according to the quill DRO. Let's see how we go with that. Alright, let's switch the focus over to trying to scribe a line on the bevel. See how we get on with that. Okay, so it's the first mark on that I've done on naught, so I'll just go back over here. And we'll turn round. I'll try and put 5 marks on. So we're good. First one we're going to go to 72. Well, I'm happy that engraving is working really well. So obviously I need to go a bit deeper than that for the final answer. And we'll see what that looks like. Oh, no. It's much too deep. I didn't like the sound of that at all. It sounded a bit like it broke the point off my scriber. Yeah, it's broken the tip off the pointer. Right, well that mistake was very unfortunate because as it turned out I didn't have any more of this diameter high-speed steel bar cutting blank, so I had to make a complete new holder to take the larger diameter stuff that I did have. Anyway, I've done all that, repeated what you saw earlier with the diametral lines to check that I'm on centre, and actually I think it possibly came out even better. I don't know whether I can do anything better to make that clearer, but your eyes are better than mine if you can see much scope for improvement. Anyway, so I'm pretty sure I'm on centre. I've done the 5 scribe lines with a depth of scribing depth of about 0.4 millimeters, and I might do 0.5 for the final go just to make them slightly deeper. So when I made these originally, I didn't put the bevel on because I was actually a bit unsure how I was going to do marks on the bevel face. So I wanted to leave my options open to reduce this to a 2mm flat disc. Anyway, now I've proved how I can do those marks, I'm ready to put the bevels on. And hopefully we'll hit our mark straight away. Yeah, that's 5mm. Actually, it's a bit hard to be sure. Yeah, that's 5. Okay, so I've done the best touch off that I can and set the depth of cut to 0.05mm, and let's see what happens. The lighting isn't very good, but it's the best I could do. And learning from the previous thing, I'm going to back it off before I return the cutter, and go back so we can have another scribe if we want to. Now what have we got? It's very difficult to see. Let's try a different camera. Okay, so I found a different camera angle which seems to give a better result. In fact, it's much easier for me to see what's going on looking at the camera rather than trying to stand on my head and look at the thing. Anyway, so that was 0.05. I'm going to go a little bit deeper. You can see the chip coming up anyway. Alright, we'll go back clear of that and have a look at what we achieved. Yeah, that's got a bit of weight to it as a groove, so I think we'll go with that. 0.15 is that's what we'll sell for. So for this one I think I'll do 3. So let's go round to 120 on to 240. Right, 3 lines. As sharp as well as I would have liked. Well, I think I'll just have to try them, and if I don't like them I'll clean the face off and do something different. Alright, well I won't bore you with any more of the engraving. Come back when I'm ready to drill pairs of holes for a pin spanner. Okay, so now I'm set up to drill a pair of holes in the face of the dial for a pin spanner which I'm going to make. I think I'll make these 4.5mm deep. Okay, let's see how that works out. Well, I think we'll be pretty happy with that. It's obviously going to work just fine. Let's have a closer look at this pin spanner that I've knocked up. So this is an old spanner lying around. Anyway, so I cut the jaws off both ends, rounded one end, called that the handle end. On the other end I drilled a pair of slightly undersized holes and cut a 1/8 of an inch diameter dowel pin in half and pressed each of the pieces into a hole. And that's it. So that's going to work just fine. This will never be a high torque thing, it's just holding it while I do the nut up. Okay, so I'll do the other two and we're well on the way. So there's a closer look at the one I've just drilled. You can possibly see that the holes are flat bottomed. That's because I used a 3-flute slot drill. Anyway, this turned out alright. You happy with that? So all that's left to do for this one now is stamp a couple of numbers on it, and it's finished. So I'll get on and do the other two. Right, well there's one of the finished items installed, and the little pin punch thing there makes it quite easy to adjust the thing, so that when you change the gears, which I won't bother to do here, you can tighten the gear up and arrange that the index marks line up properly with the peg on the TDI body, which always used to annoy me when the mark's off one way or the other. You've got to anticipate. Okay, well I guess it's finished making these spindles. It's a good project, gave me plenty of opportunity to try out the new lathe and come to grips with that. Also let me resolve an issue with this supplied spindle which I didn't like, and my new arrangement I think is somewhat easier to work with, so happy about that. Made a couple of tools along the way. I didn't show any video of that, but anyway, that's now part of the toolkit for the lathe. Had to make a new one of these along the way as well. Well, they're becoming useful for something else, I suppose. As to the markings on the dials, I was concerned that they wouldn't be big enough and bold enough, but I think as we just saw, that no, they're in fact just fine. The pinholes worked out fine, and even the number stamping worked out. So all in all, I'm quite happy with the outcome. So, hope you enjoyed the video, and look forward to seeing you on the next one. Cheers.